Here, so recording. So welcome to our Introduction to Networks meeting for June 7th. First off, everybody, we do have this class officially ends on June 10th, but you know we're continuing. So the only thing that's going to end is you won't have access to canvas.stanley.edu anymore after June 10th. You will still have access to netacad.com and NetLab, so that is not changing. But just be aware that from June 10th until your class starts again on July 27th, you will not have access to a class inside of canvas.stanley.edu. So that's the only thing that's going to change for you. Now, what I did for everyone is I did go in, I emailed you, but also put it inside of the class. I made a revision for our syllabus just to give us another set of dates for you to kind of look at if you need them to look at when you need to be done. If you are working on the old syllabus and you feel like you're going to be finished in the next week or two, then by all means continue to do that, and I'll turn the final on for you, and you just let me know, and I'll do that. But the big thing you have to finish up is obviously the skills exam lab final, which has to be completed in our NetLab system, and I'll show you that in just a second. And then the course feedback and the final written exam, which is inside of Netacad. So one of the things here on NetLabs, when we go to do our hands-on final, when you log in here on netlabs.stanley.edu and you scroll down or you go to do a lab reservation, so lab for myself, your hands-on final is inside of the class itself. So in other words, here's your spring cohort. And I have not turned it on, so I've got to turn it on. So here's a lesson in how NetLabs works. I don't have in your class the hands-on final content turned on because I didn't want you getting confused about that being in there. So let me go ahead and turn it on for you real quickly. So here, you'll notice there's a content tab right now. The only thing available are the labs. But if I go in here and turn on the MDP skills assessment, so it's multi-device pod skills assessment, that actually turns on the hands-on final inside of NetLabs for you. So now, if I go to do a reservation, and you look in the class, you're going to see a new lab available. You're going to see a skills assessment. This is your hands-on final. This is what you must complete in order for you to do the hands-on portion of this course to pass it. So when you click in here and actually go in, I'm actually going to do a reservation and show you, because I want you to see the lab or the actual skills assessment. But you're going to notice that when we get in here, I'm going to give it just a couple seconds to boot up. But when we get in here, it's going to look very familiar to something we did last Thursday, which is why I kept mentioning last Thursday that was very similar to your hands-on final. When we get in here, I'll show it to you, but it takes it a few minutes because this is real gear booting. It's, down in my data center right now, there's real routers and switches. But look at how familiar this looks to the lab we did last week that I worked on with you in class. And your content is right here. And you will notice it's going to ask you to pick one of these networks, or it says your instructor will pick one of these networks for you. You are to do this network right here, 192.168.10.0/24. Subnet A should be subnetted for 100 hosts. Subnet B should be subnetted for 50 hosts. So the very first thing you have to do is for this assignment is print this out, and then you're going to do a subnetting, and it tells you exactly how to do it. Now, anywhere it tells you to have the instructor sign off, you're going to just work through that. So you work through this all the way to the end, and then you will send this sheet to me, and I will go check your lab inside of NetLabs. But you'll notice again, look at how familiar this is to what we've seen before. All right. So very important that you go do that as part of the final part of our class. Now, you are not, if you're not ready for that, that's fine. You'll notice I put in new dates here. This week, we're finishing module 11, which we've already finished. Next week, there's really actually no assignments. I'm having you catch up. So I'm actually going to lecture on module 12 today to talk about IPv6 addresses, because we talked about those last week. And many of you didn't, we had not lectured on it yet. So obviously it was a little bit difficult for you. So I'm going to talk about IPv6 addresses. But put this together for you to get you kind of a, from here on out, where to go. If you want to move forward, you want to work quicker, that's fine. But this is where we're going to kind of work from here on out throughout till July 27th, which will be when your next class starts. So we have to be finished with this course, and I'm shooting for us to be finished the week of 7/19. So sometime between 7/19 and 7/27, you should be finishing everything in this CCNA 1 class. Any questions about that? I'll stop my video so we're not taking up screen real estate. Any questions about what we're looking for? If you're not ready to do the hands-on final yet, that's fine. You've got, what, 4 more weeks. Actually, almost 5 weeks left. You can do it. 1, 2, 3, 4, 5, going on 6 weeks. So we've got time for you to finish up this CCNA 1. So I'm very glad we could do that. Yes, go ahead.
Professor Kelly.
Yes.
Although I make a mistake on the, I think the one of the assignment on 10, the one that you will not be able to return the equipment back, I mean the cable back into the rack.
Right.
That's exactly what happened, or I know I've already did it in NetLab, but I'm not worried about it.
Right.
I was just worried about.
I looked at that one and tried to figure out how, and if you, I don't know how you deleted the cable because I couldn't delete it. So it must have been connected to another device or was laying on that table in the item. The only way I could see to fix it was to actually reset the activity. The bad news is that resets everything, so you would have lost all your work up to that point. But I couldn't find any other way to do it. I couldn't find any other way to reset it. So I tried and couldn't find it. So I don't know. I don't know whether it was, again, had been sat down on, you know, when you're doing that packet tracer physical mode, it may have fell down onto the table, but I couldn't make it do what had happened. So I'm thinking it was probably connected to another device and you kind of lost sight of it. But that's all I had. That's all I could figure out on that one. Now that one was one you said you did it on NetLabs. You saw how much easier it was on NetLabs. And also it was
easy in the NetLab.
Yeah, it was a good lab too. I mean, that's a good lab to just do basic, give you your basic router configuration. So, okay, any other questions? All right, let's talk about IPv6. So one of the big problems we know and we're all aware of is there are no more IPv4 addresses. So we're out of IPv4 addresses. They have been gone for some time. You'll notice that IPv4 has been exhausted in North America since 2015, in Latin America since 2011, and the latest was Africa. It's gone. There are no more IPv4 addresses anywhere left in the world. So the maximum of 4.3 billion addresses are 100% gone. So we have to do something to allow us to have more addresses, and that is IPv6. We know IPv6 is 128-bit address space, which is supposed to give us 320-something undecillion addresses, which is enough for every single grain of sand on the planet to have an IP address, theoretically. And for a very long time now, we are going to have the coexistence of IPv4 and IPv6. The most common method for that will be to have devices running both IPv4 and v6 at the same time. It's called a dual stack method. By default, Windows machines have IPv6 turned on, and they also have IPv4 turned on. So you're really probably running dual stack now, whether you knew it or not. The other way we're going to see is possibly doing tunneling, and this can be IPv6 being tunneled in IPv4. Typically, it's a dual stack router where you've got an IPv6 network. You tunnel it in IPv4 to get over to another IPv6 network. And then this has kind of gone the wayside. They still show it. They call it NAT 6-4. So it's natting IPv6 to IPv4. They really kind of have depreciated this as an idea. And the recommended method, if you've got to support both, is to do dual stack. So that's the way we're gonna be looking at going forward, is to run both. But let's look at how IPv6 is represented. It is 16-bit segments or hexstets. You'll notice here as we look at each hexstat, there's 1, 2, 3, 4, 5, 6, 7, 8 hexstats for 128 bits. Each one of those hexstats are 16 bits each. So you'll see 4A12 16 bits, and they are represented using hexadecimal. We have some formats here. Now, normally, you see how long these addresses are? We have some rules that make our life working with IPv6 addresses much, much easier. If we had to type out these super long addresses all the time, it would be extremely difficult to do. But thankfully, they've come up with some rules. And rule one is you can always omit leading zeros. So you can look at some of our formats here. If it's 0 dB8, it can become dB8. If it's quad zeros, you can just put 0. Same thing here, quad 0, 0. So this long address becomes 2001 dB8 0, 1111 colon 0 colon 0 colon 0 colon 200. All right, so we can always omit leading zeros. That's rule one. Rule two is what's called the double colon rule. This one gets people in trouble because the double colon can only be used to replace a single contiguous string of one or more hexstats containing all zeros. So in our instance here, where we've got 2001 dB8 0 0 0 all ones, all zeros, 200. You can change this to 2001 dB8 colon 0 colon all ones colon 200. And we know that represents, so it's normally it's 1, 2, 3, 4, 5, 6, 7, 8 hexstats. This shows us there's 1, 2, 3, 4, 5, and then this would say there's 3 hexstats of zeros in the middle here. That's why it's very important. It can only replace a single set of contiguous zeros. If you put 2001 dB8 colon AB00 colon, you wouldn't know that it was 2 here and 3 here, or 3 here and 2 here. So we can only replace a single set of contiguous zeros. So this would have to become this right here, 2001 dB8 colon 0 colon 0 colon AB00 colon. So we know there's 1, 2, 3, 4, 5, 6, 7, 8. So we know there's 3 hexstats here of zeros. So only single contiguous segments. Now notice this gets very useful for things like linked local addresses. We're going to learn about linked local addresses, which are FE80. So instead of having to put in FE80 and all these zeros, we can just put in FE80 colon 1, which tells us there are 6, 1, 2, 3, 4, 5, 6 contiguous zeros in these hexstats. So remember, we can get rid of leading zeros, and we can have a double colon that allows for one set of contiguous zeros to be represented by double colons. And then they go through and give you all these examples. So if you wanted to omit leading zeros, you could put this in 2001 dB8 0 1 2 3 4 5 6 7 8 90 101 90 101 11 12 111 12 1113. And then the compressed format, there's really not much of a compressed format you could do here, but you could do this. You could technically do 2001 dB8 colon 1 2 3 4 colon 5 6 7 8 colon 9101 colon 1112 colon 1113. Yep. Now that's not much of a compression, but it is something. And then you can just continue to reset, and it will keep showing you. You can actually get more and more examples, so you can practice this. So it's an HTML5 practice thing for you. All right. Now, IPv6, unlike IPv4, it's a little different in that there are 3 different types of addresses that we deal with. You'll notice there's no broadcast. There's Unicast, which is a one-to-one, so a single IPv6 enabled device. There's multicast, which is sent to a group of devices. And then there's a very weird thing called an Unicast, which is a group of devices, but the first one that sees it responds. Now, I will tell you, Unicast is not really covered in this class, but imagine it to be a, it's like a multicast that only the very first device that responds is responsible for making a response, or the first device to see the request is responsible for making a response. So we're not going to cover Unicast, but we will talk about Unicast. Now, in a Unicast address, there are two parts. There's the 64 bits that is considered to be the prefix length, which is the network portion. And then there's 64 bits that are the interface ID. The interface ID is similar to what we would call a MAC address, but there's a couple different ways you can get it. We'll talk about both those here in just a minute. But the big thing is, on an IPv6 address, 64 bits are the prefix, 64 bits are the interface ID. Now, we also, if you look down here, this is where things start getting a little confusing, in that we don't typically assign multiple IP addresses to an interface. Now, what I'm going to do in here on this router, so I'm going to go ahead and just do a big T, and I'm going to give it a host name, R1. I'm going to do line con 0. I'm going to do a logging synchronous, so I won't have to worry about that. I'm also going to do a no IP domain lookup. All right, so that's taken care of, so I don't have to worry about my mistypings. So I've got two different interfaces here. I've got gig 001 and 000. So what I'm going to do is I'm going to go into interface G001, and I'm going to put an IPv6 address on it. And you'll notice it's very simple. It's just like IPv4. I'll put 2001 colon DB8 colon ACAD colon. I'm going to make this subnet 1 colon 1 /64. So there's my address. But I will also be placing what's called a link local address on this. So IPv6 address FE80 colon 1, and I'm going to call it link local. Now I'm going to go over and assign IP addresses to my other side. I hit the up arrow because I'm lazy. So this side will be 2. Now notice this is the prefix. So, oops, I messed up there. Hold on a second. So the prefix here is, for this one, 2001 DB8 ACAD colon 2, so /64. And the interface on this one is .1. So I'm manually setting the interface ID right here. And then this is where people get very confused. I just put the same link local address on both sides of router 1. And that is because with IPv6, link local addresses are only significant on your local interfaces. So in other words, it's okay to have the same address on all the interfaces on router 1, as long as on the links that router 1 is connected to, they are unique. So let me give you an example here. An example I did. This is actually an example I used last week, but I'm going to actually pull up another thing. So if I've got router 1 here, and router 1 is connected over to router 2, and it's also connected to a switch here, and a switch here, and a switch here. I can put FE80 colon 1 as the link local address for every single one of these interfaces. The same address, as long as no other device on those links have that same address. So over here on router 2, I would use FE80 colon 2 as the link local address. So these link local addresses, they're called link local addresses, are only significant on the links, and they only have to be unique on those links. They can be the same if you're on different actual networks. Does that make sense?
Can you repeat that, sir?
Yeah. So link local addresses, okay, are only significant and can only be used on a single link. So if I put FE80::1 on this interface and on this interface, that is fine as long as no other device on that link has the same link local address. If you don't set a link local address, by the way, if you don't statically set it, the router and devices will assign themselves a link local address that is unique on that link. We like to set it on our routers because it's used for the default gateway for our IPv6 devices. So this allows us, when we set these, to make sure we know what our link local address is on the devices. That is in contrast to what are globally unique addresses. Okay, our global unique addresses are routable. By the way, link local, these are GUAs. These are IPv6 GUAs. They are routable. Link local addresses cannot be routed. There's no way to route those across any network because they are only for local use. So let's go back over here just a second. So looking right here, you can see these routers use the link local addresses to send information to each other with their routing table updates. So as long as this router and this router don't use the same link local address right here on this link, they're fine. But this router in the middle could use the same link local address on the right and the same one on the left, which is exactly what I just did in this lab. I set the link local on both sides to FE80::1. Now, one of the things I forgot to do and haven't done yet is a very important step. By default, IPv6 Unicast routing, IPv6, I might want to actually put V6 in there. IPv6 Unicast routing is not turned on. So by default, Cisco routers will not route IPv6. So if you don't turn that on, the router will not route it. But this, I do a do show IPv6 in brief. Notice all I had to do is change the commands to have the IPv6 and it works the same, but you'll see here the link local address is FE80::1. And then on this side, it's got the global unique address of 2.1, and then down here 1.1. And I shortened that obviously, 2001 DB8 ACAD. So our global unique addresses, all right, that's one type of address we can assign. That's the routable global address, just like a routable global IPv4 address. We will also always have link local addresses. That's required for every IPv6 enabled device. So if you look at your PC right now, if I look at my PC, you will see that I've actually got link local addresses on my PC. So right here's the interface. You'll see an FE80::, and then you'll see this strange number right there. So this is what's called a derived link local address. In other words, this machine took and said, okay, FE80::, and then it picked a random number, random 64 bits for the host section or for the interface ID. It's not really the host, it's the interface ID. For the interface ID, and applied that as the second portion. That's what typically Windows machines do in order to get the interface portion. All right. We then have loopbacks, same as IPv4, except this one's : :1. Unspecified is : and then really these unique locals, we're not going to go a great deal into them, but unique local is kind of used for the same thing as it was supposed to be like private addressing. So it was supposed to be like almost like a NAT type thing for private internal addresses, but they were not, they really were not ever really used. So we're not going to talk a lot about unique local. We just don't even really use those out in the real world. So But we do use this, globally unique addresses. Typically right now, we're only handing out the first 3 bits, or actually we're only getting the first 3 bits being handed out by INA, and they're being handed out in blocks to ISP so that they're easily not subnetted, but easily reduced to smaller routing tables. I'm sorry, I had a block there for a minute. But you'll notice that we have typically what's going to happen is your ISP is going to give you a /48 global prefix. Now here's where you need to think about how crazy this is going to be out in the real world. Your ISP is going to give you the first 48 bits. Now you remember the first 64 bits make up the prefix, so the network portion. But they're going to give you the first 48 bits, some number. And then at your house, you're going to have another full 16 bits. So think about that. You're going to have as available for you, okay, up to 2 to the 16th subnets at your house. And each one of those subnets can have 2 to the 64 interfaces or hosts on it. Now you think about the waste that is. Now they're saying, now we're being told, it's not really a waste because we have so many addresses. But you're going to learn how easy it is to subnet with IPv6. It is literally just saying, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 65,536, actually 2 to the 16th. So whatever you've got there, which I believe is 65,000. So we've got a huge, huge amount of space that we're going to be given to use. So we've got our global prefix, which is that first 48 bits typically, and then our 16-bit field that will be our subnet, and then our 64 bits that will be our interface ID. Now again, the link locals, the range is actually FE80 to FEBF, so it's actually a /10. However, almost all link local addresses are FE80 : something. Nobody's using the others, but it's set up so that you can have communication on the interfaces without having globally unique addresses. So you can do things like share routing tables. You can do what's called router solicitations and router advertisements that we will talk about here in a minute. All right. So we can set static IP addresses easily on a device. So if we want to put globally unique GUAs on a router, we just go in and use the Ipv6 address command, and we set that interface to have that IP address on it. So this is the 2001 DB8 ACAD1 prefix, and using the .1 interface ID, and then ACAD2, .1, ACAD3, .1. All right. And you just assign them there, do a no shutdown, and it works exactly like any other router, any other IP address. No different. On a Windows host, you can do the exact same thing. You can just go in and put a static IP address. Now you got a couple options though, as far as your default gateway. You can put the globally unique address here, or you can put the link local address here. We'll show you why that may be useful in just a minute when we get to how you can get IP addresses. So you also can set, instead of, by the way, if you don't set a static link local address, the router will create its own link locals when you do IPv6 unicast routing. It will actually do that, but it just makes life more difficult on you. This is kind of a weird set of link local addresses they put on here. They put in a different one on each one, which makes very little sense, because typically we're going to use the same one on each interface. We'll do FE80 : 1 on router 1, 2 on router 2, so on and so forth, which is what I did here. Okay. Now I will show you something. What you see how it's saying it asks for networks? Here's why. By default, on IPv6, on these Windows PCs. These PCs were set up so that under DHCP or under IPv6, it would get an IP address automatically. So let's go in here and look at this. So we're going to see, this is PC A. I'm going to scroll down here to IPv6. You'll see it's set to obtain an IP address automatically. So if we go over now, and since we've set IP addresses on the routers, on the router itself, so this router should get an IP address from the network that's on G001. So it should get an IP address that is on the 1 network. So let's go look at A. We'll pull up our command prompt. We'll do an ipconfig, if I can spell it right, ipconfig/all. And you will notice that it's got an 2001 DB8 ACAD:1. So it's on the 1 network, and then it created itself an interface ID. And for Windows boxes, what they do is they create a random interface ID. So you can see this machine somehow got an IP address just by us putting IPv6 addresses on the router. So if I go to B, B should have, you can see it's saying, yes, I've found a network here. B should have an IP address. God, I cannot type today, y'all. Should have an IP address on the 2 network. So you can see here 2001 DB8 ACAD2. So how did PCA and PCB, how did they get this information? Even though we didn't set up a DHCP server, we've not set any DHCP server up, but these devices now have a globally routable address. They did it through the process of what is called SLAC. Okay, so what happens when a device boots up or a device is set to get an IPv6 address automatically? There's 3 different methods that can be used to give that device an IP address. Method 1 is called SLAC, or Stateless Address Auto Configuration. That's what that means, Stateless Address Auto Configuration. When the device boots up, the very first thing it does is it sends out a router solicitation, okay? That solicitation says, is there a router out there? But it's not, by the way, it's an ICMPv6. It says, is there a router out there that can give me a prefix to let me know what network I am on? And by the way, they use their link local addresses to send that out. That's why those link local addresses must be on each device, on every interface. The router sends back the prefix and says, yes, I am on the network 2001 DB8 ACAD:1. Just like I set my router up to be on, I said it's on that /64. The device will grab that and then will use a process, either a randomly created client ID or interface ID, or it will use a process called EUI64. We'll talk about in a minute. EUI64 has actually been stopped being used by most vendors because it used the MAC address as part of the interface ID, and that was being used to track people. And so they quit using that for privacy concerns. Now you will notice with SLAC alone, here's the bad part. The PC only gets a prefix. It does not get a DNS server. It doesn't get any optional items that it needs. So there's no DNS server here. This is just 100%, all you're getting is a prefix. Now, you still are able to have connectivity because, you know, I can actually from here, well, if I want to actually type that out, I'm not going to try to ping, but I could ping between these two right now if I wanted to, even though it takes a whole lot of typing to do it. All right. Method 2 is what's called SLAC with stateless DHCP. With this, The host still sends out a router solicitation message, says, hey, is there a router out there that can give me a prefix? The router sends back a router advertisement message with the prefix and says, here's your prefix. Also, okay, so in your default gateway information, which you got up here too, you got your gateway and you got your prefix. But then it says, also, you need to go talk to this DHCP server and get some information from the DHCP server. So with this, we would actually have to have a stateless DHCP server set up somewhere, either in Windows and Linux on the Cisco device that would hand out items like DNS. Okay. This is nice because it still allows us to very easily give IP addresses out to our clients. The final method, which is method 3, is stateful DHCP. And this is how we've done it in the past. The client sends out a router solicitation message. The router responds, oops, sorry, I can't really help you. You need to go talk to the stateful DHCP server. The DHCP server would have scopes on it. And then that scope would be used to give out all the information to the router, or to the device, except for its default gateway. It would still have its default gateway, but that was it. It wouldn't have anything else. So it wouldn't know what IP address it was supposed to use, and it wouldn't know any of the options that are common. So these 3 methods are all ways to dynamically get an IPv6 address. This is completely new. This is completely part only of IPv6, and it shows up in different places. So you need to know about it. You need to know these methods. We have a lab on it. So you're actually going to do a lab on it. And you're going to do hands-on labs that have you setting up this and looking at it. So be aware that it will work inside our labs, and you'll be able to do it, and you'll be able to understand a little better once you do the labs. Now, here is something we talked about, how do interface IDs get created. Now, today, our modern devices just generate a random 64-bit address. It used to be they used a process called EUI64, which is what they would do is they would actually take the MAC address, which is 24 bits. They would break it apart in the middle. So right at the middle of the OUI, the organizational unique identifier, and the serial number, the device identifier, they would break it in half, put FFFE in the middle. Okay. So they put FFFE in the middle, and they would switch the 7th bit. So you basically go 7 bits in, and if it was a 0, make it a 1. If it was a 1, make it a 0. And so that was how it's called the universal local bit was reversed, and that was to ensure there was no way you could have 2 EUI64s that were the same. But if you ever see an interface ID and it's got FFFE in the middle, that typically means it is one that has been generated by EUI64. This is no longer used, again, because if you had this and you were able to get the information from someone who was using IPv6, you could track it right back to their PC, because all you had to do is reverse engineer this interface ID back to the MAC address, and then you could track it to that MAC address. So they quit using EUI64 because of privacy concerns. Any questions about that? Now I want to ask you, why would this type, especially just pure Slack, why would this be so useful in a network? How could this be useful in a network? You know, the device boots up, it says, hey router, I need to know what network I'm on. And the router says, you're on this network and here's your address. Now you can go out to the internet and do, you know, you have full global unique address. How could that be useful? Anybody? Think of some ways it could help you as a network administrator.
It make it easier to make a mistake from configuring it. I think that's one of the advantage.
It do what?
Make it easier.
It is easier. One of the reasons it's so much easier. Here's something I want you to think about. What if I changed ISPs and I needed to change the actual, so right now I do a show IPv6 int brief. And so my ISP had given me the networks 2.1 and 1.1. How much work does it take if I needed to change my IPv4 addressing scheme in a network? Have any of you ever had to change an addressing scheme in a large network? It is a nightmare, an absolute nightmare. Watch this though. Watch how easy this is. So if I want to go to gig 000, okay, I'm gonna put no IPv6 add 201 :db8 :acad 2 :1 /64. Okay, now let's do a do show IPv6 int brief. Just see it's gone. So I still got my link local, but I don't have my I don't have a global address on there. Now what's this? We're gonna do, by the way, Control A takes me all the way to the front. Control E takes me to the end. So I'm gonna make this now B, because B is just, oops, B is just 11, right? Hit enter. Okay. Now I want this machine here to get a new IPv6 address. What I should actually be able to do, and I may have to shut it down and bring it back. I may have to shut the interface down and bring it back up. But I have renumbered this network to be B. So now it's B:1. Everybody's up, so I'm up. All right, let me go ahead and do that. Let me just shut this. I will tell you, sometimes you have to shut the interfaces down on Windows and bring them back up so that it will take the new network. Oops. So I'm going to disable it, which shuts the network down. I'm going to re-enable it. As long as Windows plays right, we should end up with an IP address that is on the B network. And take a peek right there. I just renumbered my network. And all I had to do was change the IP address on the interface of my router and tell everybody to reboot their machines. And I just was able to change it. So that's the kind of usefulness that we have when we have the ability to make changes and use Slack, stateless address auto configuration. Okay. We've already saw, I talked about those, I talked about that. So dynamic addressing, talking about IPv6. This is, again, what we got. This is the UI64 versus a randomly generated one. And almost all operating systems now use a randomly generated. They do not use UI64. Okay, so even Cisco routers no longer use EIU64. They use a randomly generated link local if you don't set it yourself. Okay. Now, IPv6 does have multicast address. So we have a well-known multicast address called FF02::1, which is all nodes, FF02::2, which is all multicast routers, or all routers, which we can use with routing protocols. And then we have solicited node, and this is very similar. People think about solicited node IPv6 multicast address. This is very similar to ARP, using an ARP packet for solicited node. This is how we can do an ARP type request, is with solicited node IPv6 addresses. All right. Now I want to talk just real quickly about subnetting IPv6, because this is going to blow your mind at how easy this is. To subnet IPv6, You literally take these 16 bits and you increment them by 1. So you have 65,536 subnets, and you can just simply go, okay, subnet 0, subnet 1, subnet 2, all the way down to FFFF, and that's your final one. So if I ask you to subnet a prefix, a /48 prefix, I mean, literally, it's that simple. I can say, okay, folks, I want you to subnet 2001. Oops, boy, that was terrible there. Subnet 2001 colon, golly, I cannot. I apologize, folks. I've got my pad up here on up above me here. DB8 colon ACAD /48, and I want you to give me 2 subnets. You literally could just go 2001 DB8 colon ACAD colon 0 colon /64. There's your first network. 1 colon /64 is your second network. You're done. You just subnetted it for 2 different networks. And then you put one of those on each side, and you assign the interface ID of 1 on both sides, and you're done. It is literally that simple, which is kind of hard to believe when you think about how hard IPv4 subnetting can be, but this is how easy it is. And then you just allocate it. So I just put the .1 here, .2 here, .3 here, 4 here, 5 here, and you're done. So it is that simple to subnet. Any questions about that? So we have labs, and you'll notice that 1292, folks, 1292 is an actual lab inside of our net labs. So it's very important. Again, I've been stressing, you must do labs inside of net labs. So here's 1292, configure IPv6 addresses, and here's another one, identify IPv6 addresses. These are labs inside of my net labs. So I need you to be doing them in net labs so I can see that you're working on real gear and getting hands-on experience with real gear. Are there questions? So don't do the PTPM, don't do this one, do the one with real lab equipment that's inside of my net labs right here. All right. You'll see, you can actually look at the preview of the lab, you can see what it does. It's, again, very similar to what you've seen before, but we're just assigning IPv6 addresses and ensuring that everything works with IPv6. All right. Any questions on IPv6? Any questions? Go ahead.
Professor Kelly.
Yeah.
With the IPv6 have any effect on the equipment, like more than the router that they have now and the modern switches?
Jacob, you broke up really badly there at the end. You talking about?
I said, would they have any effect on the new router or new switch?
No, you're talking about having an effect as far as it should work perfectly fine on a new router or switch. The only thing I do know is one thing you have to do if you're working on a 2960 switch. Okay, 2960 switches by default. They may not have on the ability to support both IPv4 and IPv6. So 2960s, there's a special step we do in the lab that turns on support for both. You gotta put preferred here. Default. And then that turns on support for both. That's the only thing that you have to do in order to turn on support for IPv6 on a 2960 switch. Today's routers and switches are made with ASICs that are designed to work with IPv6. So it won't really have a big issue on it. Now, I will tell you this. I will say this. We go all the way back to the very beginning of what I was talking about, how we're going to support both inside of a network. So we talked about coexistence and we talked about dual stack. If you turn on both IPv4 and IPv6, it is going to affect the router in that it's going to have two routing tables. It has an IPv4 routing table and an IPv6 routing table. And as we get even further down, what you're going to learn in our next class is you're going to learn how to actually do routing with IPv6. And so at that point, we're now going to be running routing protocols for IPv4 and IPv6. So a dual stack environment does use more CPU and RAM on your devices because you're having to maintain two sets of layer 3 protocols. So that's where you would have an effect on your networking equipment. Having said that, since most of this equipment has been designed from the ground up to support the ability to do dual stack, the result, unless you have a really big network, should be fairly minimal strain on your devices, on your networking devices. Does that help? Does that make sense?
Yes.
Okay, Jacob, you were real low, or whoever's very, very low on that because I didn't get a response there. But does that make sense to everybody?
Yes.
Okay.
I have to do some work.
Yeah, yeah. I will say once you start working with IPv6, you're going to find it's not as hard as what you think. Typically, if you need to do a command that's associated with IPv6, take the IPv4 command and just type IPv6 instead of IP. So if it's a show IP interface brief or a show IP route, by the way, let me real quick, I'll go back over here and show you again on this. You know, typically if we wanted to see the route on a router or the routing table on a router, we would type show IP route. Well, people will do this and go, well, there's no routes. What's going on? I know I've got IPv6 in here. Well, remember, show IP route only shows IPv4 routes. Show IPv6 route, and now we see the networks we're actually connected to. Same thing here. I do a show IP int brief, and it doesn't show me anything as assigned. Well, that's because there are no IPv4 addresses assigned. But if I do a show IPv6 interface brief, now I can see the IPv6 addresses that are assigned to the interfaces. So typically, anytime you need to do something with IPv6, just take the IPv4 command and put IPv6. All right. Any other questions? Any questions about the revision to the dates that I gave you? Any questions about those? Any questions about what is going away on after June 10th? Remember, you will not be able to get into canvas.stanley.edu anymore. Well, you'll be able to get in there, but you won't see our class in there after June 10th. Now, our class will continue on. We're not stopping this class. We will meet Mondays and Thursdays. And I hope that was useful for everybody on Thursday that was able to make it or was able to review that. Tomorrow or this Thursday, we're going to do some more labs on actually subnetting. We're going to do one or two of the subnetting labs as time permits. And as we go forward, we'll just continue on from here on out, working on the labs that are available and showing you things, showing you items. I do want to spend one class period before this class ends, showing you how to create a class, the process of adding students to a class, some of the basic day-to-day management tasks that you have to do for a class. All right. Now, anybody has any questions or any problems about getting in the classroom? Okay, let me show you what's going away. Okay, after June 10th, you know, right now you can log into canvas.stanley.edu, and if you log in, you can see our class. We've got the first cohort right here. You can actually go in the class. After June 10th, you will not be able to see this inside of canvas.stanley.edu because your class will have ended. So your official class will have ended, but we will continue to meet. So the only thing you won't be able to get to is this. You'll be able to get to netacad.com. You'll be able to get to netlabs.stanley.edu. You just will not be able to see our class inside of here. And remember, the only thing we really had here was the ability to jump to these other sites. So you can just go directly to them instead of having to go through our Canvas site. Does that make sense? Does that help?
Yes, because you won't be able to go that way, but you can still go through NetCat and go to the classroom, see your grades, see your course, see your progress, et cetera.
Exactly. Exactly.
Okay.
Yep.
Because I
Everything-
actually haven't been really going in the classroom. I just go directly to it.
Exactly. So that's why I'm saying for most people, it won't even affect the way you've been doing anything, because we really only use Canvas for that very first assignment. And then we go directly to our other sites
Okay.
by just putting in netacad.com and netlabs.stanley.edu. So excellent. Yeah, that's exactly right. So it's going to have a negligible impact after the official class end date.
Is that why that person keeps emailing to complete the survey?
Well, no, that is one reason. And it's also, the survey is inside of Canvas, and it will be gone after June 10th. So if you can do the survey, I would appreciate it. I know our class hasn't officially ended, but it will, the official end date is the 10th, and we've extended, we've all agreed to extend it so that we can work to get y'all completed with this CCNA 1 without everybody going crazy. But yeah, if you can do that, I would appreciate it. We will have actually the ability for you to do feedback inside of netacad.com too. But that's our on-campus feedback. I think they actually they put you in a drawing for a gift card or something like that. So, okay, everyone, I have got to run. I've got a Skills USA meeting I've got to get to. Let me stop my recording.